So in the last problem with the dog running on the water, I mentioned that this is an example of symmetry. So we used the water, well, we used the shoreline as a line of symmetry. We reflected our point down here the exact same distance. So symmetry is a powerful tool for solving all kinds of problems. So I'm going to give you another one, and let's see if you can figure this out. I'll give you two versions of it. Here's the tricky version. I don't remember where I saw this problem the first time. If I think of it, I'll put it in a title somewhere. But I didn't come up with it. So imagine that, let's say you have a room and you have one of those Japanese style, what do you call them? Those paper partitions, those little walls that you put up. So you want to set up a little one here to add and you want it to have the most space as possible. So we'll say that it's like a bifold. It has two halves, fold in the center. So what is the shortest, what is the most area that you can fit in here? So let's say I will just draw, I don't know, something like that. So the bifold partition has a hinge here. Each side of these is equal, even though it doesn't look like that in my drawing. We'll say that this side is equal to this side. How can I put these so they're touching each one of these walls and we have the most space as possible in here? Here's a simpler problem of our Japanese bifold partition. What if instead of having a bifold partition, it was just a single straight piece? We'll say this red line is the partition. Now it doesn't have a hinge in it, so it just has to stay straight. And we can even think of this as a simpler problem with just a right angle and drawing a line across. What makes this the largest? If this stays the same length, how do we make this as big as possible? So that might give you some insight into the problem. However, there's an interesting property that shows up that you might not notice if you deal with this case here. You might notice it, but this might be too easy and you might not rely on the symmetric argument. So if you played around with it for a while, it might not seem super obvious, but you probably gained some insights. You can see that, for example, a really shallow angle like this is definitely smaller than what we have here. And likewise, if you did something like if we inverted the angle like that, it's probably not the best. Maybe you think it should be at a right angle to the wall. Like that. You know, we often think of things in squares and boxes, but for this problem, you're going to have to think outside the box, or the square in this case. So I'll show you how the symmetry works to solve this problem here. So I'm going to redraw the corner of my room again. And I'm going to make some symmetry lines here. So this is the corner of the room we're concerned with, but I'm also reflecting it across this symmetry line here, and this one here, and then this one here. So we now have the corner of the room reflected 3 times. So we have 4 copies of the room. Whatever shape I draw for the configuration of the bifold partition, that's also going to be reflected across all 4 of them. So the bifold partition has 2 sides, right? And we have four total copies, counting the original. So we're going to have an 8-sided shape. Now, what's the best, the largest area that we can take up with the 4-sided shape? It's a regular octagon, right? That would be the best. So if we draw that, I'll draw it in green. Okay, that's not a perfect that's not a perfect octagon. Sorry about my sloppy drawing, but I think you get the idea. So the solution to our non-bifold partition is, we might be able to find it by means other than using the symmetry argument, but we would miss out on the beauty of that solution. So, if say this here is our original room corner, it looks like this. And then we have our reflections here as well. We can see that it's a diamond shape, or it's a perfect square, actually, if we rotate it like this. And you might have noticed, if you start playing around with it, you know, without these symmetric pieces here, you might have realized that it should be a 45-degree angle on each side here, or a triangle shape like this.